Okay, our last example is overlapping triangles is the official name of this picture. Down the road we're going to get overlapping right triangles. Right triangles have the Pythagorean theorem involved. Overlapping triangles do not have the Pythagorean theorem involved. So as you get more information, like a right triangle, they're going to give you less numbers. So in this picture I need 4 numbers and 2 letters to be able to solve. When we get to the overlapping right triangles, we're going to have 3 numbers and 3 letters, because Pythagorean theorem is going to be something we can use to find something. As with all figure problems, you have a picture, there's properties associated with that picture. What I want you to recognize about this picture is this triangle on top, this triangle with 4 and 9 and 7 as sides, has these 2 angles in it. This angle marked 1 and this angle marked 2. Notice we have this angle marked 2, and we have this angle down here marked with 2, right? There, so those are equal to each other, right? What I also want you to notice about this picture is that this big triangle, which is right here, contains the small triangle, but it also is the big triangle on its own. It also contains this angle up here. So both triangles have this red angle, but it's the exact same angle. Even if they don't tell you that one's equal, it's the same angle, so it's equal. So that might be one of those where they leave that information off, but you can make that assumption that those angles are equal since they're the same angle. These 2 angles have to be marked as equal, or they might tell you these 2 lines are parallel, which will make these 2 angles equal and these 2 angles equal. All right, so types of things that could be thrown into these overlapping triangle problems are those things. So the main idea of this is it's a similar triangle problem, just like the other similar triangle problems we've had. How we determine the angles to be equal is a little different. All right, so in this case they've given me these 2 angles in the blue triangle are equal to these 2 angles in the red triangle. If 2 angles equal 2 angles, the third angles have to be equal to each other. So those 2 angles have to be equal to each other. And again, I said I would do this one using proportions. So if I'm doing proportions, what I'm concerned with is the corresponding pieces, as always. With overlapping triangles, we have to be a little cautious about our pieces. Okay? Look at the red triangle. How big is this piece? 10. Okay? This 6 is important. It's how far it is from here to here, but the red triangle side is 10. Okay, now that I've used the 6 to get the 10, I'm going to throw that out. The blue triangle side is 4, right? Those 2 sides are both opposite the black angle, so 4 and 10 correspond to one another. Looking at the red triangle, what's the length of this side?
Y.
Y. Very good. It's exactly Y. There's no 2 pieces making it, it's just the 1 piece. That's opposite the red angle. In the blue triangle, this is opposite the red angle, so 9 and Y correspond to one another. And then looking at the red triangle, this side is how big?
7 plus X.
7 plus X. X is important. X is how far it is from here to here, but the length of the side includes that 7. So once you've established the length of that, we no longer need this piece. 7 plus X opposite the blue angle, 7 opposite the blue angle. Those sides correspond to one another. Alright? Be careful, we're using addition. Segment 1 plus segment 2 equals the long segment. Segment 1 plus segment 2 equals the long segment. We're always adding those up. I've seen a lot of people want to multiply those. They'll write 7 times X there, but again, 7 plus X is what we get. 4 plus 6 is 10. If I'm using proportions, the middle proportion is the one that's the key. I want just numbers in the middle fraction, right? Just numbers. And if you look at my corresponding pieces, all numbers, number and letter, right? So the black ones are all numbers, so I'm going to put 4 on top, 10 on the bottom. I could have just as easily put 10 on top and 4 on the bottom. Make a decision. It doesn't matter what you put where in that one. All right? It does matter at this point where we put everything else, though. Since I chose to put 4 on top, where does 9 belong?
On top.
Where does 7 belong?
On
On top. 4, 9, and 7 all come from the blue triangle, so 4, 9, and 7 all have to be on the same side of the fractions. So since 4 is on top, I made that decision already. Everything from that triangle goes on top. And the other stuff from the red triangle goes on the bottom. So 9's on top, Y's on the bottom. 9 and Y go together. 7's on top, 7 plus X is on the bottom. 7 and 7 plus X go together. All 3 of these measures, Y, big triangle, 10, big triangle, 7 plus X, big triangle. So making your good proportion, everything on top comes from one triangle, everything on the bottom the other triangle. Each fraction represents corresponding pieces. Now we're ready to solve. The reason we want the numerical one in the middle is because then I can just do, this proportion is going to get me y. 4 times y equals 9 times 10. Again, fractions are fine as answers. 90 over 4 reduces to 45 over 2. I would take 22.5 or 22.5 for that one, but again, I personally believe it is an improper fraction. Looking at the other one, this one, be careful with overlapping triangles. You do get binomial pieces quite often because you're adding pieces together, and a lot of times one of those pieces is unknown. This type of structure is quite often there. When I do 4 times that stuff, I'm going to get 4 times 7, which is 28. Plus 4 times x is 4x. That's going to equal 70. So be careful the distributive properties happening when you're distributing, or I should say when you're cross multiplying. Single thing times multiple things, multiply both things by that number. Move the 28 over. So 4x is equal to, looks like 42. Divide both sides by 4. Again, reduce if possible. 21 over 2 is the best answer for that one. Allow yourself a little bit of think time on each problem. Don't spend 10 minutes of think time on each problem, okay? That's too much think time. But think through the problem. Make sure you focus on properties. If you set up a proportion, make sure that you put a lot of thought into everything from one triangle on top, everything on the other triangle on the bottom, corresponding pieces of each fraction. Get that setup properly done. And the more you do it properly with the thinking, the quicker you'll get as you do it. And it'll speed you up in the long run.